Okay, so let's jump right in. We all use a ton of stuff every single day, right? From the air we breathe to the phones in our pockets. Some of these things, well, they seem endless. But what about the ones that aren't? Today, we're going to talk about the fuels that power our entire world, coal and petroleum, and a little something I call the popcorn problem. I want you to picture this for a second. Imagine all of our planet's most precious energy sources are sitting in one giant snack bowl. Now, we're all sharing from it, but not just with each other. Right now, we're sharing it with our kids and their kids and so on. So that leads to a pretty big question. Are we eating all the snacks? Is there going to be anything left for the next person in line? So here's how the analogy plays out. You've got a full bowl of popcorn. That's all of our finite resources. The first generation comes along and they take whatever they want. Then the second generation, which is even bigger, comes and does the exact same thing. So by the time the third generation finally shows up, what do they find? An empty bowl? A few sad little kernels at the bottom? It really all depends on how much the folks before them left behind.
And of course, this isn't really about popcorn, is it? We're talking about something called exhaustible resources. Specifically, we're talking about fossil fuels, things like coal, petroleum, and natural gas. And the crazy part is, they were all formed from the remains of living things millions upon millions of years ago.
First up on our list, coal. And you gotta understand, this stuff isn't just some black rock we dig up. No, it's more like a time capsule. It's literally buried history, ancient history, that we now burn for energy. The story of how coal gets made is, well, it's epic. Picture this. 300 million years ago, the planet was covered with these incredible, dense, swampy forests. As all that plant life died, it got buried under layers and layers of soil and muck. And then, over millions of years, a ton of heat and pressure basically cooked those dead plants, super slowly changing them. That whole process is called carbonization, and it's what turns ancient trees into the coal we use today. Just think about that, a recipe that takes 300 million years to finish.
And here you see it in action. Our modern world is literally reaching back into deep time. Every single piece of coal that comes out of a mine like this is a chunk of a prehistoric forest. It's packed with solar energy that was captured by plants long before the dinosaurs ever even walked the earth. It's just wild to think about.
So what do we actually do with all this ancient energy? Well, pretty much everything. For a long time, it was used for cooking and to power those classic steam trains. Today, though, its main job is generating a huge amount of our electricity in thermal power plants and fueling all sorts of industries.
But here's where it gets really, really interesting. We don't just burn coal. When we process it, we get some incredible stuff. We get something called coke, which is this super pure carbon that you absolutely need to make steel. We also get coal tar, this thick, black, gooey liquid. And you would never guess what comes from that. Dyes, drugs, plastics, and even perfumes. From coal? Who knew?
Okay, so that's coal. Now let's talk about its famous cousin, petroleum. If coal is the buried sunshine from ancient forests, then petroleum is pretty much the buried history of ancient oceans. And it's so valuable, it's earned a very famous nickname.
Yep, black gold. That name really says it all, doesn't it? Its commercial importance is it's almost impossible to overstate. It's the lifeblood of our modern world, especially when it comes to transportation and industry.
And you know, the name itself gives you a huge clue about what it is. Petroleum comes from two Latin words, petra, which means rock, and oleum, which means oil. So it's literally rock oil. Makes sense, right? Because that's exactly where we find it, trapped in rocks deep under the ground. Now, the recipe for petroleum is a little different than the one for coal. This time, our story starts in the ancient oceans. Millions of years ago, tiny little sea creatures died and their bodies sank to the ocean floor. Over time, they got covered by layers of sand and clay. And just like with coal, the combination of intense pressure, high temperature, and no air slowly turned their remains into the crude oil and natural gas that we drill for today.
But here's the thing. The crude oil that comes straight out of the ground, well, you can't just put that in your car. It has to be sent to a place like this, a petroleum refinery. A refinery is basically a giant, complex factory that sorts the oil, separating that dark, crude liquid into all of its different useful parts.
And what comes out of that sorting process is just incredible. From one barrel of black gold, you get everything. You get LPG for your barbecue, the gasoline for your car, the diesel for trucks, and the fuel for jet airplanes. But it doesn't stop there. You also get lubricating oil, paraffin wax for candles and Vaseline, and even the bitumen that's used to make paint and pave our roads. It's literally everywhere in our lives.
All right, that brings us to the third big player in the fossil fuel family, natural gas. It's often found hanging out right alongside petroleum deposits, but it's got a few special tricks up its sleeve that make it really important. So, why is natural gas such a big deal? Well, it really boils down to two main things. First, it's super easy to transport through pipelines over huge distances. And second, when you burn it, it's cleaner. It produces less pollution than coal or oil, and that's a pretty big advantage.
You've probably heard of it as CNG, right? Compressed natural gas. Because it's cleaner, it's a fantastic fuel for vehicles like city buses, helping to cut down on smog. And those pipelines mean it can be supplied directly into our homes for heating and cooking. On top of all that, it's a key ingredient for making important things like chemicals and the fertilizers needed to grow our food.
So, there you have it. Coal, petroleum, and natural gas. Three absolutely incredible, world-changing resources. They're amazing. But this brings us right back to where we started, back to the popcorn problem. Because, we're starting to see the bottom of the bowl.
You see, in nature, you've basically got two kinds of resources. On one side, you have the inexhaustible ones, like sunlight and air. We're not going to run out of those. But on the other side are the exhaustible ones. And fossil fuels, they are definitely in that second category. There's only so much of them, and once they're gone, they are gone for good. And here's the part that is it's kind of hard to wrap your head around. Nature spent hundreds of millions of years slowly, patiently creating these fuels. And us? We're burning through all of the known reserves so fast that they might only last a few hundred years more. It's like nature spent millions of years making a giant savings deposit, and we're trying to spend it all in one weekend.
And it's not even just about the supply running out. There's a whole other side to this coin. The very act of burning these fuels comes with a cost. It's a major cause of air pollution, for one. And, as we all know, it's a huge driver of global warming. So we've got a double problem: a supply that's shrinking and some serious consequences for using what's left.
So, what can we actually do about it? Well, there are some simple, practical things. Things like driving at a steady speed instead of racing from red light to red light, switching your engine off if you're stuck in traffic for a while, making sure your tires have the right amount of air. Just basic vehicle maintenance. They're not huge, dramatic changes, but they really do add up. It saves you money, sure, but the bigger picture? It leaves a little more popcorn in the bowl for everyone else.
And that brings us to the big final question. We can't make more of this stuff. That's a fact. We can't just whip up a new batch of coal in a lab. It's a super slow, high-pressure natural process that we just can't copy. So knowing that the bowl actually has a bottom, what's our next move?